Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something.
Hey, welcome back to our machine learning class. In today's video, we'll be primarily focused on the steps involved in machine learning and the classification of machine learning domain. In this section, we'll be walk you through the steps of machine learning and provide you with example to illustrate the process. After that, we will proceed to discuss the classification of machine learning and its related applications. In this part, we'll be looking at an example of machine learning process. Here are the steps involved. First, we collect relevant samples, which could include search data and a question bank. These samples will serve as foundations for our learning process. Next, we extract features from the collected samples. This involves classifying and organizing the knowledge contained with the samples. Once we have the features, we convert them into a format
that can be processed by the machine learning
algorithms. This includes standardizing the data within specific range, such as getting it between 0 and 1, or -1 and +1. This step helps simplify complex problems and make them more manageable. With the prepared data,
we move on to train the data.
Training the machine learning model. This involves using data to teach the model how to make accurate predictions or classifications. Finally, once the model is trained, we can use it to predict new instances, such as in an exam scenario. Model will utilize the knowledge it gained during the training phase to make predictions on unseen data. So, these examples demonstrates
the step-by-step process of machine learning.
From data collection to feature extractions, data conversions, model training, and predictions of new instances. Let's dive into a case study to further understand the process of machine learning. In this case, we want the machines to automatically
recognize objects as either chopsticks or toothpicks.
Here's how we approach it. Firstly, in the initial step, we gather a set of samples that includes both chopsticks and toothpicks. We measure certain features of this object such as length, weight, and material. We then pile these samples into a table, which displayed the features of each sample belongs with its corresponding category. Moving on to the second step, we begin the process of feature selection. In this example, we easily realize that the material of the object doesn't provide any useful information for distinguish between the chopsticks and toothpicks, so both types can be made from various materials. Therefore, in this step, we eliminate the features of materials from the consideration. So, what we have now is a two-dimensional feature space. One dimension represents the length of the objects, while the other dimension represents the object's width. Our next step, the third step, is to use the data to train our model. We want this model to be able to determine whether an object is toothpicks or a chopstick based on its length and weight. This process is known as training the model or model learning. The data we use to train the model is called the train set, or training samples. In this case, we have selected a specific model for training. Our goal is to ensure that the classifiers can accurately classify different types of data and separate them into their respective categories as much as possible. By continuously training model on the training set and adjusting its parameters, we eventually obtained a line that separates the different classes of the data. Now, for the first step, we need to assess whether the model has ability to predict new instances. This ability is known as generalization. To evaluate this, we use a separate set of data called test sets or test samples. We feed the test set test data into the model and compare its predictions with the actual results. By doing this, we can determine the accuracies of the model on the test sets, which represents its generalization ability. The accuracy told us how well the model performs in making predictions on unseen data. Next, we'll learn about data preprocessing. First, it's important to note that there's no standard process for data preprocessing. However, it generally involves 6 steps.
Removing unique attributes, handling missing values.
Attributes coding.
Data normalization, feature selection, and dimensionality reduction.
Removing unique attributes, handling missing values is variables in the data sets
that are unique to each samples, such as ID or name. These attributes are typically not informative and cannot be learned from in terms of their semantics.
Handling missing values involves
filling the missing data with method like taking the means, medians, modes, or using model predictions. Attributes encoding refers to transforming attributes into data type that model can't directly process. Data normalization scales the attribute values to unified range, ensuring that each attribute carries equal weight. Feature selections involve selecting the variables that are variables for the model predictions using specific methods. And the dimensionality reductions, on the other hand, reduces the number of attributes using mathematic transformations while retaining the most of the information. These steps collectively aim to prepare the data in a suitable format for the machine learning model to effectively learn from and make accurate predictions. To explain these concepts more clearly, let's look at an example. Here, we have a data set with 4 samples. The attributes include ID, name, age, income, gender, education level, and expenditure. Following data preprocessing steps we just learned, our first step is to remove unique attributes. It's evident that ID and name are unique for each samples, so we can easily identify them as attributes to be removed. Next, let's take a look at sample 3, where the expenditure attributes is missing. We can use common sense or other method to fill in the missing value in that spot. Then we proceed to encode categorical variables in the datasets. This means transforming them into numeric values that can be understood by the machine.
By following these data processing steps,
we can ensure that the data is in the suitable format for further analysis and model training. This is a transformed dataset after data preprocessing. We have removed the ID and name attribute and filled in the missing value in sample 3. We have also qualified the gender and education level attributes into numerical properties. The resulting dataset is shown in the feature below.